Hi class, welcome to lesson 1 of unit 4. In this unit, we're going to explore the periodic table. In today's lesson, we're going to focus on how the periodic table was developed and organized, and what are the similarities and differences between periods and groups. The good news is, on every Regents exam, you will be provided with a 12-page Regents reference table. The periodic table is there, so there'll be very little memorization. Instead, you just need to know how to use your reference table and find the information asked. The father of the periodic table was Dmitri Mendeleev. He was a Russian scientist who conducted many experiments and decided to organize the elements according to their chemical properties. What is cool about his original periodic table is he was able to find gaps and able to predict the existence of elements that were not yet discovered and identify the properties that they should have. The one problem with Dmitri Mendeleev's table is that he organized the elements in order of atomic mass. Now this is called a periodic table because he noticed that the chemical properties periodically repeated. The periodic table we have is organized in order of increasing atomic number, that bold number found in the lower left-hand corner on your periodic table. Moseley, who worked with Ernest Rutherford, decided to organize the table in order of increasing atomic number. He had to add noble gases later, as noble gases were very unreactive. So Mendeleev, based on reactivity, was unable to discover noble gases. They are unreactive because they have complete valence shells. The periodic table has 7 periods, or horizontal rows. Each period, the elements have the same number of principal energy levels, also known as electron rings. All other indicators like atomic number, nuclear charge, and valence varies across the period. The vertical columns are called groups or chemical families. All of the elements in the same group have the same valence electron number, the same oxidation state, increasing number of principal energy levels, and very similar chemical properties. Our periodic table actually has a section cut out. This lower section that represents a unique energy level are called the lanthanides and actinides. On our table, we cut out this section so that our periodic table is less wide and requires less paper to print. Some elements exist in multiple forms. An element that can exist in multiple forms are called allotropes. Examples of these are oxygen. Oxygen can be diatomic like the oxygen we breathe, or triatomic, making up the ozone layer. The different molecular shape always results in different properties. Now let's try some practice Regents questions. In the first question, we are looking for elements with the most similar chemical properties. Recall that similar chemical properties can be found in the same group. Use your periodic table to find which 2 elements are in the same group. Now you can easily answer number 2. In question number 3, we are looking for which groups of elements contain diatomic molecules at standard temperature and pressure. Since we are not calculating conditions with gas molecules, standard temperature and pressure is not important here. Here we're looking for a diatomic element we must memorize the 7 diatomic elements. I like to remember, I brought clothes home from Old Navy. In question number 4, we are looking for an atom in the ground state. Recall the ground state is what's listed on the periodic table, has a stable valence electron configuration. That means that it has a complete valence, which is either ending in 2 if it is helium, or 8. In question number 5, we're asked to find which ground state Lewis dot structure is correct. You need to begin by remembering that protons identify the element. Use the protons to look up the element and its electron configuration. Only valence electrons are in Lewis dots. Remember, there are many ways to draw Lewis dot diagrams. The Regents does not always use my technique, but they always put the correct number of dots. Just look for the correct number of dots. Answer question 6. There are 5 major groups of elements that you will have to memorize the names of. There are other groups that we will not have to memorize the names of. Recall that a group on the periodic table is a column. The elements in the same group have the same number of valence electrons, the same possible ion charge, and therefore they react very similarly. Group number 1 is known as the alkali metals. These are the most reactive metals on the periodic table. Please note that hydrogen, a nonmetal, is not part of the alkali metal groups. They will have characteristics of metals, meaning they'll be shiny, malleable, and ductile. Here is a Regents question that asks you to explain why elements lithium and potassium, both found in group 1, have similar chemical properties. Make sure that you don't try and memorize the periodic table. Always look up the data before you decide on your answer. So on our reference table, we see the mass number of lithium is approximately 7, while the mass number of potassium is approximately 39. The atomic number of lithium is 3, while the atomic number of potassium is 19. When we look for the number of electron shells, we have to refer to the electron configuration. Lithium has 2 electron shells, while potassium has 4. The last choice is valence electrons. As you can see, lithium has 1 valence, and potassium also has 1 valence. Recall that valence electrons are the outermost electrons. These electrons have the greatest amount of energy because they are furthest from the nucleus. Group 2 are called the alkaline earth metals. These are reactive metals, but not quite as reactive as group 1. They have 2 valence electrons. They will have all the properties of metals, so they'll be shiny and ductile, malleable, and good conductors of heat and electricity. Group 17 is one of the 2 groups of nonmetals we need to be familiar with. The halogens form many diatomic molecules. They have a -1 charge and are the most reactive nonmetals. Group number 18 are called the noble gases. All noble gases have complete valence shells. They are highly unreactive as their valence is already complete. Unlike halogens, all noble gases are monoatomic. Group numbers 3 through 11 are a special set of elements called transition metals. They are all metallic in character, but they have variable positive oxidation states. They transition between these, hence the name transition metal. Finally, these elements tend to produce colored solutions. Human blood is red because it contains the transition metal iron. Colored paints and other pigments also typically contain transition metals. In addition to knowing the 5 major groups of elements on the periodic table, you should also be able to distinguish metals from nonmetals. We discussed the properties of metals and nonmetals back in Unit 1, but if you forgot, you should be sure to write down this list. In addition to the properties discussed already, we know that metals form positive ions or cations as they lose electrons. This process of losing electrons is also known as oxidation. It is called oxidation because typically these metals lost their electrons when they reacted with oxygen. They will actually lose their electrons when reacting with any nonmetal. Nonmetals form anions or negative ions by gaining electrons. The process of gaining of electrons is called reduction because the oxidation state or ion charge is reduced. Recall that atoms always have a charge of 0. So if we go from a 0 to a negatively charged ions, our charge is reduced. Metalloids can be found along the bold stair step on your reference table. Metalloids have properties of both metals and nonmetals. Remember that elements must have 2 lines of this bold stair step touching them in order to be considered metalloids. Also remember that aluminum is a metal. I know you already knew that. Now it is time for you to show your knowledge by answering these questions. In the first question, we are looking for a brittle nonconductor. Brittle nonconductors typically describe nonmetals. In addition, if it's brittle, it must be solid. So here, you're looking for a nonmetal solid. In the next question, we're looking for a solid that is a good conductor of electricity. In this case, we're looking for a solid and a metal. In the final question, you're looking for 2 metalloids. Recall that metalloids exist on the bold-colored staircase. Polonium is not traditionally described as a metalloid. So, before you answer, remove polonium as a choice. That concludes Lesson 1, Introduction to the Periodic Table. If you have any questions, make sure to write them down and we will address them in class. See you soon!